My name is Kastrup. I'm a postdoctoral fellow here at MIT in the Koch Institute. I work in the lab of Robert Langer and Daniel Anderson. So our lab as a whole is interested in delivering drugs to specific areas of the body. That's one major focus of the lab. And me in particular, I'm interested in synthesizing and making materials for cardiovascular applications. So one of the materials that I've been developing is an adhesive coating that can adhere to blood vessel walls. So the idea is to take this adhesive coating, incorporate drugs into it, and coat it over diseased areas of the blood vessels. To walk you through what we're looking at in the image, on the bottom is the blue is the blood vessel wall, and then on the wall you can see that there's purple particles and green particles, and these green and purple particles are inside of this vascular paint, this hydrogel. And so these green purple particles have essentially been glued or coated onto that blue blood vessel. The way that we were able to image these is we incorporated fluorescent dyes into the different particles and into the blood vessel wall, so that using a fluorescence microscope, using a particular microscope, we could detect these signals from the vessel wall. The key problem that we had to overcome was getting material that could strongly adhere to the blood vessel. So inside of a blood vessel, there's blood rushing through it, and any material that would be put against the blood vessel wall would easily flow away. The adhesion comes from the same chemistry that marine mussels use. So marine mussels, they adhere to a wide variety of surfaces underwater. So they can stick to rocks and plants and boat hulls, and they can do it with waves crashing over them. And so when we were trying to design an adhesive material, we thought that the chemistry that marine mussels use would be the ideal system. This image for us conclusively told us that we could do this. We could paint materials on a blood vessel wall, and so now we're exploring a range of applications for this technology. The first thing we're testing is whether we can coat and heal atherosclerotic plaques. In the long run, we'd like to take this material and deliver it to blood vessels that are feeding other diseased areas such as tumors. And so what this adhesive hydrogel would do would fill the vessels leading to tumors and release therapeutics that can go and then stop that tumor from growing.